Hello students, welcome to Short Sir classes. So today we'll be solving another question from mathematical statistics part. So this question, in this question, first I'll read out the question. In the simplest type of weather forecasting, rain and no rain in the next 24 hours, suppose the probability of rain is P greater than half and that forecaster scores a point if his forecast proves correct and 0 otherwise. In making an independent forecast of this type, a forecaster who has no genuine ability predicts rain with probability this and no rain with probability 1 minus lambda. Now prove that probability of forecast being correct for any one day is 1 minus p plus 2p1 into lambda. Hence derive the expectation of total score Sn of the forecaster for n days and show that this attains its maximum value when lambda is equals to 1 and variance is this, and thereby deduce for fixed n this variance is minimum for lambda equals to half. So we'll do this sum. For this, what we have to do is, first it is given, that is probability of raining on any day equals to P, which is greater than half. So probability of raining on any day is equals to P, which is P is greater than half. Now P, that is forecast is true. So probability that forecast is true equals to forecast is true equals to this equals to P, he forecasts rain and it rains, plus he forecasts no rain and it does not rain. So from here we can say that probability that is raining on any day is equals to P, which is greater than half. Now P is nothing but probability of forecaster's forecast is true equals to probability that he forecast rain and it rains, that is he forecast the right thing, and he forecast no rains and it does not rain. So this is the probability that forecaster's forecast is true. Now what we have to do is, write down lambda p plus 1 minus lambda 1 minus p. So probability of this we have put it to be P, and probability of this we have put it to be 1 minus P. So when it rains and it rains, when he predicts rain and it rains, we give it lambda, and 1 minus lambda we give when it does not rain, as we have got it from the questions. Now what we have to do is, we simply take a random variable, let xi be a random variable defined as follows. So xi is a random variable defined as follows. xi is equals to 1, if forecast is correct for ith day. So if forecast is correct for ith day, we take xi to be equals to 1. Now if forecast is incorrect, we take for ith day, we take it to be equals to 0 and I is equals to 1, 2 until n. Now we have to find expectation of xi is equals to 1 into, as we have said, x is equals to 1. We know expectation of xi is nothing but probability, summation probability into x, that is px. So x is 1 and the probability then is xi equals to 1. So similarly, when it is 0, the probability will be xi equals to 0, which is probability xi equals to 1. So we are left with probability xi equals to 1. Because it is 0, it gets cancelled out, we are left with this. Now from here what we can do is pxi equals to 1 is nothing but p probability forecast is incorrect for ith day. Sorry, forecast is correct for ith day. So it will be correct. Forecast is correct for ith day. So probability of forecast is correct for ith day. This is nothing but xi equals to 1. So we have found it. So expectation of xi equals to 1. Now we can also write it as lambda p plus 1 minus lambda 1 minus p. So we can also write it as lambda p 1 minus. So here we can write lambda p plus 1 minus lambda 1 minus p. Now from here if you solve it, we will get the value to be equals to 1 minus p minus lambda 1 minus p lambda p. Similarly we get it to be 1 minus p plus 2p minus 1 lambda equals to mu. We assume it to be equals to mu. So forecaster's total score for n days is given by, now we have to write the forecasters so now the forecasters total score, which is Sn for n days, Sn for n days is given by Sn equals to summation xi I tends to 1 to n, which is equals to expectation of Sn. Now if you take expectation of x10, which is equals to expectation of summation expectation of xi, this xi, which is equals to n into this summation will become n, and expectation of x will become 1 minus p plus 2p minus 1 into lambda. So we have found it to be Sn equals to this. Now since it is given in the question, since p is greater than half, hence 2p minus 1, which is nothing but half, p equals to half, is greater than 0. Hence Esn, this is Esn, expectation of Sn is maximum when lambda is equals to 1. So when lambda is equals to 1, we say, or lambda is maximum, we say Esn also maximum. Now we have to find the variance of Sn. So the variance of Sn is equals to variance of summation xi, so which is nothing but summation variance of xi. Now variance of xi equals to expectation xi square minus expectation xi whole square. So now we'll simply put the values, which is 1 square probability xi equals to 1 plus 0 square probability xi equals to 0 plus minus mu square which is equals to mu minus mu square. We have already assumed it to be mu in the earlier section of this video, which is equals to mu 1 minus mu. So we have found it to be mu 1 minus mu. Now substituting it in this, substituting this value in this, we get it to be equals to variance of Sn equals to, variance of Sn becomes n into mu 1 minus mu. So there is summation sign was there, so which becomes n into mu 1 minus mu. So now which is equals to n into 1 minus p plus 2p minus 1 lambda. So we can write it this way, which is p minus 2p minus 1 lambda, which is equals to n ab. Instead of this we can write n ab lambda minus b lambda square equals to function of f lambda. So f lambda, say, so we have assumed it to be f lambda where b is equals to 2p minus 1, which is greater than 0, and a is equals to p 1 minus p. Now if you take first order differentiation of this, we'll get it to be f dash lambda equals 0. So the value of lambda will get it to be half. If you take it to be equals to 0, the value of lambda will find to be equals to half, and f double dash lambda will become equals to minus 2b, which is less than 0. So we can state that variance of Sn is max when lambda is equals to half. So now we'll go to the question again. So if you go to the question again, you will get to see that we have proved that a variance of Sn is maximum when lambda is equals to half. So thank you for watching this video. If you have any query or doubt, I'll be giving you my number, which is 9836 793076. It is 9836 793076. Or you can also go to our website, which is www.shouropsclasses.com. There you will find a lot of other videos like this, and you will get study material for mathematical statistics. Thank you for watching this video. Have a nice day ahead.